Hello, can you hear me?
Yeah, can you hear me?
Yeah, yeah. All right, how's your evening going so far?
It's going well. I just woke up from a nap. So.
All right, that's good. Now, so you won't need to take any breaks in the middle.
Yeah, hopefully not.
Awesome. So have you used this platform before?
No, it's my first time.
All right. Yeah, it's pretty basic stuff. We're just gonna pick some language for you to do a programming challenge in, and you'll code it up, and you can run it. And yeah, that's kind of about it. The only thing that we need to do just to get started is picking a language that you want to work with. There's like a little, it's a whole big list of various things.
Yeah.
Like Python and JavaScript, C, whatever.
Yeah, sure. I would like to say I want to do it in Python, but I'm not too familiar with it. I definitely want to switch eventually, but I'm just gonna use Java for now.
Okay, well, let's just do Java then. Nothing wrong with that. Cool. So I'm just going to dive on into to a programming challenge, and then at the end, if you have any questions for me, we can do that then. So my first question for you is whether you're familiar with the concept of order statistics, like finding the third largest number in a set of numbers, something like that.
Yeah, I definitely heard of that before. I actually kind of need to go to the bathroom right now. Is that okay? I'm really sorry.
Yeah, no worries, no worries. Just come back whenever you're done.
Okay, yeah, I'll be 5 minutes. Yeah, I'll come back. All right, thank you. Hello?
Yep.
Yeah, sorry about that. Back now. Sorry, I had a bit of stomach pain.
No.
You're talking about the orders,
Uh,
statistics?
yeah. You doing all right?
Yeah, I'm okay now. Yep.
Cool. All right. So let's just start by implementing some basic forms of this, and then we'll sort of expand it and make it more and more general. So for the first one, just to get us started with the platform and everything, let's just start by finding. I'm just gonna, I guess, just leave this here. I'll write down the instructions down here. Write a function to determine the third smallest number in a set of numbers. So you'll get you'll basically, in this class up above, you'll define a function. Just make it static. Int, and you'll call it third smallest, and it will take a set of does that make sense?
Sure. Yeah. Sure. Okay. Let's get to it. So public static int third smallest.
Yeah. So it can be run in the platform in Java. You'll want to make it as part of this class.
Oh, you're right. Of course. Yep. Third smallest. And you're given a set of integer candidates. So the third smallest number. So what if the size of candidates is less than 3? Say the candidates was like only containing 2 numbers.
Just return null. That's fine. All right.
Okay.
Oh yeah. Never mind. Return 0.
Okay, gotcha. So I'm gonna first approach here to first find the size of the candidates. And then I'm gonna say if that's less than 3, I return 0. What's jumping at me right now is to then sort the candidates. So if I sorted it, then I could return the third smallest element simply by starting from the last element in the candidate and moving kind of 2 over.
Mm-hmm.
Okay, so I'm going to try to sort it. And so I know in Java you can do arrays.sort, and set is, not sure if I can call it on a set directly. But we'll try that. And then I'm going to say that the third smallest is walking 2 over from the end. So int result was candidates dot get size minus, so size minus 1 would give you the last one. So if I add 2 to subtract 2 from that, and then it would be minus 3. Return result. So let me see if this works for a small set. So maybe 1, 2, 3.
Yeah. So you'll put the so go ahead and put the example in the static main void up there.
Oh, okay, sure. So I can do set integer numbers, nums, new hash set. So do I have to like actually add the numbers in? I guess I do
Yeah,
for
you
run.
add them.
So nums.add 1, add 2, add 3. At this point, it's hopefully it's 1, 2, 3 in the collection, and then I would need to call it, so return third smallest nums.
Why don't you try printing it out? That'll be easier to see.
Gotcha. Into line. Try that. Misspelled the line here. Okay. So let me try to run it. Cannot get symbol. Yeah. Okay, so I guess you can't call arrays.sort. So arrays.sort is expecting an array. Wondering if there's a way to just convert candidates to an array, to array.
Take a look at the
oh, sorry, I didn't hear what you said. Hello?
Yeah, feel free to a to array method. So yeah, you're right. That will turn the set into an array.
Yeah. And if that's the case, I would probably have to do candidates using array notation here, if that really changes it to an array. Array required.
So to array doesn't actually change the type into an array. It returns an array that contains all of the candidates that you have.
Okay, so it doesn't change it to an array. So my candidates are still a set, I'm assuming. So let me see if this old way will work.
The set is so when you call candidates.toArray, candidates, the set doesn't change. It just creates a new array and returns it.
Oh, gotcha. So maybe I can save that somewhere, right? So int sorted equals arrays.sort, and then instead of using candidates, I can do sorted sorted.length. So -1 will give me last element, I move 2 over. -2. That'd just be -3. Let me try that. Void cannot int. So maybe arrays.sort does not return an array. I would have to look at the documentation.
Right. So what does arrays.sort? So does arrays.sort create a new array and return a pointer to it, or does it sort the arrays in place and return a void? And you can definitely look in the Java documentation if you want to take a look.
Yeah, sure. I'm gonna do that right now. I need to brush up on this. So I'm looking at the Oracle docs right now. It says, let me go to the sort method. So it says it returns void. Static void is a return type. Sort the specified array into ascending numerical order. I don't see the method that takes in a set though, although I'm sure there is one because it didn't have a compiler. Let me just Google arrays.sort Java on set of integers.
So the problem isn't with the input. So arrays.sort here is taking in the result of calling toArray on candidates.
Right. I already turned.
So arrays.sort is the input is an array.
Gotcha.
The issue here, and you're really close. So the issue here is just that arrays.sort doesn't return any value. It's a void, and it actually just works side effect of taking whatever array you gave it and sorting it in place.
Gotcha. Okay, so in that case, I can't assign it to anything because it doesn't return anything. And then I would need to, so if I just call, so if it turns my set into an array and my candidates is an array at this time, I'm wondering if I can just do candidates.
So candidates doesn't change at all. So candidates.toArray doesn't change candidates. It returns an array with a copy of all of the data that has all of the integers in it. So after you call toArray, there's now two separate things. There's candidates, and there's the array that was returned by that function call. So what you're going to want to do, and you had the right intuition with storing the sorted array, but you need to do it a little different way, because in essence, you're losing that array by writing it this way. So you call candidates.toArray, it creates an array, arrays.sort sorts it, and then you have no way of accessing it at all. So you're like one line off from having this work.
Okay. So I'm still kind of looking at the docs for sort, and it says it's still a static void. So as you said, I was in the right ballpark with the setting it equal to. But it says it's static void.
So you're close, but that's not quite it. It's almost there.
Okay, so looking at the docs, it says, maybe I can go on a different website. So it sorts, okay, java.util.array is a sort, taking an integer array, sorts specified array of ints into descending numerical order. Does not return any value. Okay. So looking at an example here where, so I don't think I can do a left-hand assignment here.
Correct.
So it says I'm sorting the array here. And then their example on tutorial's point, they sort the array and then they just kind of access each number in the array. And
so do you want to try storing the array first before sorting it, so then you can have access to it later?
Oh, okay. Okay. So if I do a temp and then I save it here, and then I would want to sort on arrays.sort temp.
There you go. Cool.
And then I would get int result equals replace candidates with temp, and then so what this does is it copies the array beforehand, sorts it, and then okay, I see. And then operates on the temp. Oh yeah, I got extra. Candidates.toArray. Incompatible type object cannot be converted to int. Array of objects can't be converted to int.
Yeah, this is a funny thing about about overload of arrays.sorts.
Yeah,
And
I wonder if I can cast it
hmm,
to int.
I think casting it to an int would object candidates a two array. Uh-huh.
Oh, that didn't work.
Set dot two array. Dot two
Um,
array. There's actually there's two different sets you can call. One is the one that you have.
okay, I think
So I'm looking at this.
Um,
So I'll just like paste the Java doc I'm looking at here.
yeah, okay.
So
Yeah. I think I'm calling the wrong version of toArray. So maybe if I call it toArray like this, and then, okay, so toArray, and then this requires an object. Contains an array containing all of the elements in this set. The runtime return is that of the specified array. So I wonder if I can do.
So yeah, this is one of the more like obscure parts of Java being a little bit weird. So just to give you a little bit of a hint here, so T in this case you want to be an int because you're trying to make a int array.
Mm-hmm.
So what you need to do is you need to pass it in an int array, which is really weird, but I don't know, for whatever reason, that's the only way that they could do it. So you have the right thing where you have candidates here, but you need to pass it in an array. So you could just do something like this. You have to pass it in some kind of int array to let it know that the type that you're going to return is an int array. And it's super clunky. If you did this in another language, it usually works out a little bit easier. But Java, in this particular sense, is just a bit clunky about the whole thing.
Yeah,
so,
definitely. Yeah, I think I remember.
But yeah,
sorry, did you say something?
No, go ahead.
Oh, okay. Oh, yeah, I definitely do remember something weird like this when I tried to use raise.sort months ago. So I think it would be like candidates.size or something. It would pass this one here. Let me try to run that. Oops. No suitable method found for toArray. Candidates.toArray. Well, I am passing an array of integers now. And I'm just declaring the size of the int array that I pass in here to be candidates.size.
Wow.
toArray, no suitable method found for toArray int. Method collection is not applicable.
Amazing. What you might want to do, so that's the other thing that's super clunky about, well, why don't you first try the form that I put in, which is just an empty array.
Oops.
And then, so it's not really used to create the array. It's just used to give it a hint about the type.
Gotcha.
See if that works.
Yeah, let me go back to what you had. This.
Let's see how that goes.
See how this goes.
Oh, it does not like. My God, Java.
Yeah, this is why I'm considering for programming interviews just switching to Python. Seems like it's a lot easier to use.
Yeah.
Okay, let me just.
So it's fine. So we can we'll get through this. So one thing you could do is you could make that an integer, like a capital I integer instead.
Um,
Does that make sense?
a capital I, so
So
the
then,
box type.
yeah,
New,
exactly.
you mean here? New integer?
Yeah, because it's trying, like, it's a little clunky. And then you have to make this one on the left also an integer with a capital I.
Oh, true. Okay. Okay, so
Let's
it's
see if
retrieving.
that works.
See if that works.
Yeah, this is a bit hard.
Oh, nice. Okay.
Okay,
Cool.
there you go.
So then we got 1 for our output, which is what we expected. We can definitely do a little more testing here. Say, we said it was 1, 2, 3, 4, 5. So I'm gonna add a few more numbers to my set, and then run it again, and I would expect it to return 3. Okay. Yeah, I think
Cool.
this
This
would
is
work.
pretty good.
Yeah. Cool.
Nice.
And then
All
the
right.
runtime
So
would be.
yeah, this thing here with the with arrays and such is definitely a bit clunky in Java. It gets a little easier. Another thing to think about is that um,
Hello?
yeah, can you hear me?
Sorry, you're a little bit for some reason sometimes you like break off a little bit, and then there's patches where I don't hear you.
Sorry. Try to speak directly in the microphone. Yeah, so there's sometimes it's a bit easy because they come with a few more things that you can on array on lists as well.
Sorry, I didn't hear what you just said for the last 30 seconds. Sorry about that.
Oh,
It's kind of breaking off. I didn't really hear.
Huh.
Maybe it's my
Right.
Wi-Fi,
Sorry about that.
but I'm using my Ethernet.
So I guess not a big deal, but just saying that. So here you've used arrays, sort of the old style fixed arrays, and for some of these programming challenges, it's sometimes easier to use lists because they have there's more things that you can do with them, and they are a little bit easier to use. Like you don't have to do so many of these little tricks like we had to do here with the 2-array thing.
Gotcha. Okay, so use lists. I'll keep that in mind.
So here's a question. So it looks like it works, which is great. What is the runtime of this algorithm?
I'd say the runtime is O of n log n, because the fastest comparison base works is O of n log n. So I call sort here, and then so that's the bulk of my complexity is when I call arrays.sort, it'll use some kind of quick sort or merge sort or something, and then that will take O of n log n time.
Okay, very good. And all right, so n log n. Do you think that there is a way to get any faster than that?
So in order to be faster than O of n log n, I'm assuming we'd want to have linear runtime. In order to have linear runtime, well, you would need to kind of scan your input array once to kind of find the third smallest. I'm thinking of somehow keeping some temporary variables and then comparing them as I go. So there's actually like a whiteboard thing here, right? It's like Oh, nice. So I have 1, 2, 3, 4. So I'm thinking if I set attempt to be 1 originally, and then oh, this is actually sorted, which it won't always be. So say you have something like this, and then the answer is this guy right here, third smallest. So I don't sort it, it would just come in like this. So I'm actually I'm not sure if there's a way to do it in O of n time. I know that if you find the maximum in this array, you can do that in O of n time. But I'm not sure if you can do the third smallest O of n time. At least nothing's jumping out at me.
So what about, so how would you find the smallest number out of a list?
So if you find the smallest number, you would kind of you would set it to the first element, and then you would go through the rest of the list and then compare each one to the first element. And if any were smaller, you would reset your smallest element, and then towards the end you would find it, and that'd be O of n time.
Okay, sounds good. So continuing with that algorithm, how would you find the second smallest in that same kind of pattern of you look at the first element, you have this base case where you take the first element and you scan the list, and each time you compare what you have saved as your temporary sort of minimum, and you compare that with the value you're looking at, and if it is the smallest, then you swap it. So that was the algorithm for getting the absolute smallest. Now, how can you extend that algorithm to get the bottom 2?
Okay, so get the smallest 2 elements. Okay. So maybe I could have I'm not sure, should I write like pseudocode for this, or just kind of talk it through?
Just talk it through. So I guess what I'm saying is it's a very similar, or there is a way to do it that's very similar to the way that you just described. So you just described an algorithm where you start with a base value, that is, you start with the first element, and that becomes your sort of temporary smallest variable. And you're always holding on to this, and you hold on to that value, and then you start scanning to the right, and each time you hit a new number, you compare what you're scanning to what you're currently holding, the single number that you're holding, see whether that next number that you scan is any smaller. And if it is, then you reset that sort of special value that you're holding on to as the current smallest value. So that was the algorithm that you described. And so can you think of a way to just extend that same algorithm so that you can get the bottom 2 elements and not just the bottom 1 element?
Sure. So assuming I had I had a set like, say it's 4, 2, 5, 6. After one pass of the array, you could see that my smallest is 2. And then maybe if I make a second pass through the array and say that keep another temporary variable, like a second smallest, and then I go through and then I compare that. Well, I can't just say if it's greater than, if second smallest is greater than smallest, because that would it would work for this case because I would get 4, and then but if if it were like if the order was switched, then I don't think that would work. So assume I have like in smallest here, and I already have that as 2, and I found that out already. So I want to so what if I set smallest to the first one in the beginning, and then I'm still having the same algorithm finding the smallest, but then for the second smallest, I'm going to say that if the next I'm still kind of struggling to see where I can get the next smallest.
Okay, so let's say that you've gone. Let's go with this 2-pass idea. So you know that you've gone through it once. You found that the smallest was 2. Now let's just run through that same algorithm again a second time, but remembering that the smallest number is 2. So you start with 4. That's just your base case. And then you go to 2, and that's the one you're looking at, and you say, oh, 2 is smaller than 4. Maybe I should set that to be my current smallest. But can you use some piece of information now so that you stop yourself from doing that? Like, if you were to set the smallest to 2 again, then you would just find the smallest number again. It's not like that wouldn't be the correct answer for the second smallest. But you already know what the smallest is. So
gotcha. So maybe if I set my second smallest to 2 originally, and then I'm looking at the next one, which is 2, and I'm saying, hey, if erase up 1, which is 2 in that case, if that is smaller than the current elements and also greater than the smallest, I want to set the smallest, because I know my second smallest has to be greater than smallest. So so in that case, I'm looking at 2. So 2 is not the smallest, so then I move on to 5, and then I say, hey, 5 is greater than the current, which isn't, which it would be less than the current. So I go to 5 and I say, hey, is 5 less than 4? It's not. So I think I get the gist of the algorithm now.
Okay. Let's code that up and see what we can do.
Definitely. So I'm gonna say static int. So maybe return an integer array of size 2. Get.
Or how about just return the third smallest? So you can just rewrite over the code. I mean, can you see how you would extend this then to go from the second smallest then to the third smallest?
Yeah, I think so. Okay, I see.
So let's try you can just erase the or copy it and comment it out or do whatever you want. But yeah, you can just keep this same.
Sure.
Yeah.
So maybe this is sorting. So I'll comment it out. This is sorting approach. And then let me try to do the approach. So let's say smallest, that's actually maybe I would like to.
You might want to keep that temp.
Yeah, I was about to say keep this temp. Kind of weird. I can hear you. I can hear myself talk now.
Huh. It might be my speaker is too loud.
Yeah, no worries. Okay.
So a little bit better?
Yep. A lot better now. Thank you. So I'm gonna say if temp by less than smallest, set the smallest. So at this point, I have my smallest. So let's try second smallest. So originally that's first element in array 2 for my base case. So it seems like I'm kind of doing some repeat work here. Maybe I can do it in one loop or something. I don't see it now though. So if temp sub I, if that's less than smallest, and temp the element in that array is greater than the smallest, also I'm going to reset my second smallest. And then I would kind of have the same idea for the third smallest. And then I would kind of copy stuff over. And then if I want to make sure that it's less than the second smallest, and the array I'm looking at is also, wait, so, oh wait, no, I think I messed up somewhere here, because now it would only be true if temp sub I is equal to smallest. Let me recheck my logic.
Yeah, you're checking to see whether it's at the same time less than and greater than another number.
Yeah. So that's never going to be true. So what was I doing with this? So yeah, so I have my smallest at 2, and I'm going to say, oh right, if temp sub I is greater, it should be, okay, so it should be less than the second smallest here. And yeah, and the array looking at has to be greater than smallest. So here, this would be less than third smallest. And then set my third smallest here, and then return third smallest. And I think this is okay, but at the same time, I'm kind of doing some duplicate work, so I'm wondering if I can have it somehow in one loop.
Let's not worry about the duplication just yet. Let's try running this, see what happens.
Okay. Sure. Okay, so I get an error on line 49. So second smallest. It's not a statement.
I think the issue is that in Java you can't start a variable with a number.
Oh, of course, right. Third, second. Yeah, I totally forgot about that rule. So I'm going to change this all to start with a character. And now let me try to run it again. Okay, return to 1, which is not what I wanted. Because 1 is actually the smallest.
Right.
So let me try to debug here. So I know my smallest should be right. So here, smallest should be equal to 1.
You can go ahead and print that out if you want, just to debug it.
And line smallest equals smallest. Debug this thing? 1, okay. And then second smallest is, that's also set to 1 in the beginning. And we're going to do the rest of my array, and I'm saying if it's greater than second smallest, and the array looking at is greater than, less than second smallest, less than second smallest and greater than smallest. I set it. So here it should be 2, and the next time I'm going through and I'm saying is 3. 3 is not less than second smallest.
All right. Well, let's double check, make sure that the second smallest is being correctly.
Yeah. Let me do some debugging. So second smallest, I can actually use numbers here. Try this out. Second smallest is the one. Oh, that is not what I want. Well, second smallest definitely is sent to 1 originally. This should be greater than, right? If temp sub I, which is 2, if that's greater than second smallest. Oh, but then it would just set it to 5. Huh. So my second smallest is definitely 1 originally, and then I'm looking at 2 now. I'm saying if that's temp sub I, which is 2, that's less than second smallest.
So you can go ahead and add some more debug statements in there, like inside the loop, if you want, to help kind of figure out what's going on in there.
True. So let me try to, maybe I'll move this guy here, and every iteration of the loop, I'll print out second smallest, and I'll also print out the current element that I'm looking at. All right. Let me run it now. So current element is 2, so it seems like it's never set. And that is because, okay, I think this might be a case because the elements are sorted and you find the smallest element in the beginning.
Well, so you've just hit on a very interesting case, right? So as you started, you happened to unluckily pick the smallest element.
Yeah.
And that's actually not a valid candidate. So, here's the idea with the first round of the loop was you said, in my loop, I'm starting and I'm going to set it to whatever the smallest is of what I've seen so far. And if I haven't seen anything so far, then temp sub 0 is definitely the smallest.
Yeah.
So the first loop is correct. But the second loop, you initialize the value to already something that's lower than what's a valid value. So it's kind of a funny edge case. So you wouldn't have run into this except that in any other ordering of those numbers, but you happen to order it in just the right way to have this edge case come out. So and it's fine. You only have to make a pretty small adjustment. So basically, what you've done is you've accidentally set the value of second smallest to an invalid value. So it can never be that. And so can you add something to your if statement to also check something to make sure that second smallest gets updated to something that's valid now?
Yeah. So my problem is it's set in the smallest. It's second smallest is also just the smallest. So ask me to my if statement.
Because the if statement is basically saying if that thing holds, then you need to update second smallest and make it something else. Mm-hmm. So in your first iteration, second smallest is
or second smallest, if that's also equal to smallest, then you also want to gotcha. Yeah, thanks for that. then I would kind of need to do the same thing, I think, for the third smallest. So here I would say or third smallest, if that's equal to well, I can maybe do if that's less than equal to second smallest. Oh, this would need to be second smallest here. So here, my third smallest is 1 originally, but I'm going through the rest of my array, and I'm saying, hey, if you're less than equal to second smallest, I also want you to update. So yeah, let's try this out.
Okay, very good.
Yeah.
So what's the runtime of this new algorithm?
So this new algorithm, kind of confused myself because I put the runtime up here. Probably should have moved this guy here. Let's say this runtime, this way of doing it would be O of n, because you're going through the array 3 times, but you ignore constants, so it's still O of n. It's better than O of n log n, especially as you get larger and larger arrays.
Yeah. Awesome. Very good. Yeah, so I think we're just about out of time. So I think that's all I had for today. Did you have any questions for me? Otherwise, I will leave some feedback on the platform with tips and stuff like that.
Yeah, definitely. I thought this was really cool. I've actually never tried this kind of in-person, almost practice interview before, and definitely helped me a lot. So like, do you get paid to do this, or are you like a volunteer or something?
No, this is a paying gig. It's a paying gig.
Oh, okay,
so,
cool.
I mean, mostly I do it because I want to help people getting into interviews. I've done many interviews in my day, and they're kind of scary when you're not used to them. So want to do what I can to help people get through them. And I think that when you first get started, you sort of trip up over little things, but if you practice and you smooth out a lot of the rough edges. So it's something I like to do, help people out with that.
Okay, cool. Awesome. Yeah, this definitely helped me out a lot. I guess one of the question I had was, I know that we spent a lot of time kind of doing the arrays out sorting in Java, and that was kind of not the main focus of the algorithm. And I guess in an interview, I wouldn't really want to be kind of wasting that time when the time could be better spent kind of finding the optimal solution or picking out an algorithm, whatever. Have you found that Java is maybe not the best programming language to use, and do you prefer like Python or something? I know a lot of my friends are doing that.
So I definitely would say stick with whatever you're most comfortable with. Okay. But whatever you're most comfortable with, make sure that these things like sorting an array and changing different types, turning a set into a list and back again, and these kinds of things, make sure that you just have them down pat so that you can do them quickly and easily, and you don't even have to think about it. You just start typing. That being said, it is a lot simpler in Python. Like literally you would just say sorted, and then it would have given you exactly what you were expecting to see, the Java thing with half of the effort. So if you're just getting started in both, I would say it's definitely worth it to play around with Python a bit. But if when push comes to shove, if you're actually doing an interview, then definitely stick with the one you're most comfortable with, because that's going to be the one that, like you said, you want to be focusing on the algorithm and not focusing on these little details. And so they're using the language you're most comfortable with will help you with that.
Gotcha. Yeah, thanks for the advice. Yeah, this is great. Thank you so much. It was great.
Okay, no problem. You have a good rest of your night, okay?
All right, you too, sir. All right, thank you.
All right. Okay, bye.
Bye-bye.